Continuing our discussion of symmetry, we just want to look at the symmetry of functions. And we can see that some functions have reflectional symmetry around the y-axis and others do not. Okay, so I've given you 4 functions here. 2 of them do not have reflectional symmetry. But 2 of them, y equals x squared, does. And this other one, y equals x to the 4th minus x squared, that's the orange curve on here. The blue curve is y equals x squared. This one is y equals x to the 4th minus x squared. Those are both even functions. You might remember from our earlier discussions. Even functions have even exponents and they have reflectional symmetry around the x-axis. So this one looks something like that. If you look at actually doing a reflection transformation on functions, you can see that if you change the x in a function to negative x, it actually flips it over the y-axis. So here's my original function in red. Blue is my new function. It has been, every point on it has been moved, it's been moved across the y-axis. Okay, so that changes the sign of x. So x goes to negative x and y is unchanged. And this is reflection over the y-axis. Likewise, if instead of changing the sign of x, you actually change the sign of the whole function, then you're going to change y. So if something's sitting right on the x-axis, it doesn't change. But if it's sitting off of the x-axis, it moves across the x-axis. Every point moves across the x-axis. That changes the sign of y, leaves x alone, changes the sign of y. So here's our rule right here. X comma y goes to x comma negative y. So the sign of y changes. If it's positive to begin with, it becomes negative. If it's negative to begin with, it becomes positive. This is a reflection over the x-axis.